In the previous video, we looked at certain characteristics of a good design. We discussed that a good design has to be correct, it has to be efficient, it should be easy to maintain, and also easy to understand by other members in the development team. So now let's take an example. So here are two pictures which are shown, and the boxes M1, M2, M3, M4, M5 are components or modules which have different functions which implement some functionalities. And now the arrows denote when one module calls some function in another module. So looking at these two designs, which do you think is a better design? Which do you think is better to understand? So can you intuitively think of why you think it is easier to understand one design over the other? You can pause this video and think about this before proceeding. So intuitively, most of you must have felt that the figure on the left is better than the one on the right. So let's look at some reasons for that. So one reason is that the number of arrows, as we said, that the number of arrows denote the communication between modules. The figure on the right, they have more arrows and it looks fairly unstructured, right? So what does this mean? This means that many modules are sharing a lot of information with each other. So in such situations, we say that the modules are tightly coupled or highly coupled. So tightly coupled modules, they share a lot of data among themselves. So if you see the figure on the right, you see that M2, M3, M2 and M5, M3, M4, M5, all are sharing a lot of data or information among themselves. On the other hand, loosely coupled modules, they do not share a lot of information between them. So for example, the figure on the left, you see that M2, M3 and M4, they do not interact with each other much, and hence M2, M3, M4 are loosely coupled. So now let's reflect on why there is a lot of information sharing between modules, right? Why do you think that is the reason? The main reason is that the functionalities are spread across different modules rather than being grouped together into a single individual module, right? So when all the functions in a module, they perform a single objective, the module is said to have good cohesion. For example, the figure on the left, you can see that M3 does not depend on any other module. The reason can be that the functionalities required by M3 are in M3 itself. Whereas if you look at the figure on the right, you can see that M3 calls M2, M4, M5. The reason being, there might be some functionalities required by M3 in M2, some other functionalities in M5, and so on. So if all these functionalities were brought together into M3, then M3 would not have to depend on the other modules. And hence, in this case, we see that M3 is a good cohesive module. So to summarize, what is coupling and cohesion? Coupling is the measure of the degree of interaction between two modules. It talks about the interaction between modules, whereas cohesion is the measure of how functions in a module they cooperate together to perform a single object. Now, here is a question for you to think about. What do you think are characteristics of a good design? Should it have high cohesion and high coupling, low cohesion and high coupling, high cohesion and low coupling, or low cohesion and low coupling? So you can pause the video here and think about which of these characteristics are of a good design before proceeding. So the thing to note is that if coupling is high, so what does that mean? There is a lot of interaction between modules, and that generally means that the cohesion is low, right? And vice versa. So we cannot have designs which have high coupling and high cohesion, or low coupling and low cohesion, right? So this rules out option A and D. So now let's look at option B, right? So let's understand what happens when modules have low cohesion and high coupling. So what does low cohesion mean? Low cohesion means that functions in each module, they are performing varied operations. And is this good or bad? So this is not good, right? Because it makes it difficult for developers to understand what the purpose of this module is. And what about high coupling? So in high coupling, a lot of data is interchanged or shared between modules. And this is also not desirable. So hence, it is important that modules have high cohesion and low coupling. So to go back to our example, the figure on the right, if some reorganization is done, like moving functions between different modules, then maybe some of the communication can be avoided. So for example, can we move functions between M2, M3 and M4 so that three of these modules are fairly independent? If we can do that, then we will get a figure similar to that on the left. So to summarize, a good design is a design which is modular. And by that we mean the problem has been decomposed into a set of modules that have only limited interactions with each other. So if different modules have little interaction with each other, then each module can be understood separately, right? Then we looked at two terms, cohesion and coupling. So when the functions of the module, they cooperate with each other for performing a single objective, then we say that the module has high cohesion. Whereas if the functions of the module, they do very different things and they do not perform or they do not cooperate with each other to perform a single piece of work, then that module has very low cohesion. And high coupling means that the function calls between two modules, they involve passing large chunks of shared data, right? And this is not desirable. So now that we have seen what cohesion and coupling is, let's look at the different types of cohesion and coupling. So there are different types of coupling depending on what type of information is shared between modules. So let's look at the first one, which is data coupling. So two modules are data coupled if they communicate with each other using a primitive data type, like an integer, float, character, etc. And this is passed as a parameter between the two modules. So let's take an example of the Amazon seller portal, right? So let's say I want to view the inventory items of a particular seller. So how can I do that? So the seller module will query the inventory module to view the inventory using a seller ID, which is usually an integer or a string, right? So this is an example of data coupling, where communication between modules happen through primitive data types. The next type of coupling is known as control coupling, right? So control coupling occurs between modules when the data is passed and this data influences the internal logic of a module. So examples of these are flags and switches. So what does this mean? So let's take the previous example itself. Now in this figure, we see that the seller module has a function known as perform actions, which takes a flag. And now based on the value of the flag, the appropriate function in the inventory module is called, right? So the seller module, it passes a variable operation flag, which can take values 0, 1, and 2, for example. And the inventory module code or functionalities, it depends on the value of this flag. So if the flag is 0, so in the inventory module, there will be different condition. So if the flag is 0, then the view inventory function is called. If the flag is 1, then add product to the inventory function is called, right? So based on what value of the data is passed, the appropriate function gets called in control coupling. The next type of coupling is known as common coupling. So two modules are commonly coupled if they share some global data items. So taking the previous example itself, so operation flag, it can be a global variable. However, this means that there may be other modules also which will have access to the operation flag variable. And it is very likely that multiple concurrent changes can happen. And this can lead to an unstable system or design. So this type of coupling is generally not recommended. And finally, we have content coupling. And content coupling occurs between two modules if one module refers to the internals of the other module. So for example, if one module branches into another module, or if one module refers to the changes in another module, right? And This rarely happens in procedural languages or object-oriented languages like Python and Java, because the data and the member functions are encapsulated to form a single unit. So content coupling rarely occurs in real practice. Now that we have seen what are different types of coupling are, now let's look at the different types of cohesion. So what do we mean by cohesion? To recap, cohesion is when functions of the module, they cooperate with each other to perform a single objective, right? Then we say that the module has good cohesion. So let's look at the different types of cohesion. So the best type of cohesion is functional cohesion, where different functions of the module, they cooperate to complete a single specific task. So let's take the example of the inventory module in the seller portal, right? So if this module has functions like view inventory, adding item to an inventory, deleting item from an inventory. So all these are functionalities related to inventory management. And hence we say that the inventory module has good functional cohesion. Now the next type of cohesion is sequential cohesion. So what does this mean? So as the name suggests, different functions of that module, they execute in a sequence. So let's take the example of order processing, right? So how do you process an order? You first create an order, and then you can check the availability of that order. And if the order is available or the product is available, then you place the order. So here you see that these functionalities, they execute in a sequence. And we see that check availability looks at the product and looks at the inventory, and hence it really does not belong to the order processing module. However, it is placed here so that different functions in the module, they execute one after the other. The next type of cohesion is communicational cohesion. So module is said to have communicational cohesion if all the functions of the module, they refer to or update the same data structure. So for example, instead of having an inventory or a catalog module, let's say we just have a single product module, right, which has a list of different products. So add, edit, delete, off, catalog, inventory, all of this happens in this module itself, right? And they are updating or referring to the same data structure, which is a set of or list of products. So in this case, the product module is said to have communicational cohesion. The next type of cohesion is procedural cohesion. And in procedural cohesion, the activities in the module, they are related by a sequence. And how is it different from the previous types of cohesion? The set of functions are executed one after the other, but they work towards entirely different purposes. So let's take an example. Let's take an example of a seller portal module, which encompasses most of the things in the seller portal. For example, it can have a login function then an add product, then add product to catalog, adding item to inventory, and placing the order, then updating the inventory and log out, right? So these activities are related by a sequence, but they work towards entirely different purposes, right? So login and log out are actually separate from adding products, and adding products are different from placing orders, right? So these should ideally be in different modules, but in this example, we see that all of them are placed in a single seller portal module. Finally, we have coincidental cohesion, in which modules have functions with meaningless relationships with each other. And this is an extreme type of cohesion, and we rarely see this in good designs.